In this lecture, I'm going to show you how to set up a binary heap. Alright, before we get started, let me give you a quick intro. So, a binary heap is going to look very similar to a binary search tree. I did a lecture on this, and if we look over here, so I have this, so we have a binary search tree here with some diagrams. Alright, so a binary search tree at most can have no more than two children. So here, if we have a parent, at no more 2 children, right? You see? And another condition was that the left child of the parent had to be less in value, so 3 is less than 8, and the right child of the parent had to be greater than the parent. So here we have 10 is greater than 8. All right, those were 2 things that had to be met to be a binary search tree. Now, for a binary heap, if we look at this here, you might say that, well, it looks very similar to a binary search tree, and it does. And now, similar to a binary search tree, that at most binary heap can have no more than 2 children. But one of the differences is that the child, the 2 children, or another thing I forgot to mention is that there's 2 different types of heaps. You have the min binary heap, or you have the max binary heap. Now this one in this diagram is a min binary heap, meaning that at the top level it's going to be lower in value and everything below it's going to be greater. But we're going to be using a max binary heap, which is like the opposite. And so in this case here, the very top root is going to be higher in value than everything below it. All right, now the difference, going back to the difference, is that everything, the children below it, below each parent node, has to be lower than the parent, but it does not matter the order. Like, remember the binary search tree that the left had to be lower and the right had to be greater than the parent. Well, in this case, both of these just have to be lower in value than the parent, and it doesn't matter the order of the children. So like here you can see in the diagram we have 8 is the left child and 6 is the right child. Well, we can do it the other way around. We can actually have 6 here and 8 here. In either case, they're both going to be lower in value than its parent node, which is what's important. That's the most important thing. Another thing is that a binary heap is a complete tree, and meaning that it goes from layer to layer, from left, working its way from left to right. So it's going to start building like at the very top, and then as it starts adding nodes, it's going to start at the next layer and go from left to right, adding these nodes, and then again until each layer is filled with its 2 children. So it works its way layer by layer from left to right. Whereas a binary search tree, I mean, you can have occasions where it can start to look like a linked list and just a straight line, or it's just these are balanced out, okay. And another thing is, so what we're going to be using to store this binary heap is an array. All right, in this diagram here we see, and don't mind that this is the min binary heap, okay. We are going to be using max binary heap, but I just want to show you guys exactly what we're going to be doing with this array. All right, so we're going to have an array here. In this diagram you can see that all these nodes, which is a total of 6, are stored here in this array here. All right, now later we're going to have to determine, if we have a parent node, we're gonna need to determine the children of it, and vice versa. If we have children, we're gonna want to find a parent, and we have these formulas here. So say as an example, here, all right, this is the parent node, and so we want to find out the left child of it, which is 3 here in the diagram. Well, the top root is always going to be the first one in the array, so you can see 1 is here. All right, 1 is right here, and we want to determine what's the left child of it. So here you can see returns the left child. So what we have to do is, by this right here, number 1 is at index 0, right? Because this is an array, so 1 is stored at index 0. So using this formula here, we do 2 times 0, which is 0, plus 1 is going to be 1. So at index 1, let's see, so 0, 1, you see we have 3, and indeed that's the left child. and you can see here to return the right child, it's the same as this one except we add 2. So if we went to the second index 0, 1, 2, it would be 6, and you can see the right child here. And again, I told you we can also find out the parent of the children, and we will use a different formula here using the index minus 1 divided by 2. All right, so again, we're going to use this later on. All right, but I wanted to show you that there is going to be a formula that we're going to be making use of. All right, so let's go ahead and just do our basic setup now for our binary, our max binary heap. All right, so we're just going to set up the max binary heap class. So here we're going to call it a max binary heap, and it's going to have a constructor. And the constructor, we're not going to have any values passed to it. We're just going to set up a default initial state, a values array here. All right, and this array is what's going to store all these values here. All right, and that is it. Let me just do this here. Call this heap new max binary heap, just like so. Save that, run the code in console. If we look at this heap here in the console, we can see we have our max binary heap with our initial setup of values, which is an array. All right, so that is our initial setup, and we'll continue on later.